Hi class, we're going to try widescreen now, so hopefully you guys can see it a little bit better. So today, the assignment that we're going to talk about is for March 23rd, okay? So this one is going to be due March 23rd. This first week of the closure is a little bit different. After that week, I'll be having assignments due when we would actually be physically in class, okay? So they correlate with what your A-days would have been. Okay, so this first one will be due on March 23rd, and I apologize, I don't have the microphone, so I'll just speak loudly. Okay, awesome. So we are going to be doing the first three together, or I will be doing them as examples for you. Okay, so I'm going to zoom in. We are talking about factoring and solving quadratic functions. Okay, so the first one, number one, we have 10r to the fourth plus 5r. Okay, so when we're factoring out the common factor, we need to look at the numbers in front first. And by that, I mean our coefficients, our 10 and our 5. Okay, so in class, we know that we can create factor lists if you need to do that. So we know that if we were to create a factor list for 5, our only two factors for 5 are 1 and 5, right? If you wanted to create a factor list for 10, we could say that 1 times 10 or 2 times 5. Okay, this way we can find the greatest common factor, the number that is on both lists that is the biggest. Okay, we know that our greatest common factor for these two lists are 5. Okay, 5 appears on both lists, it's the highest number, right? It would not be 1, 1 is smaller than 5. Okay, so we know that between 10 and 5, the GCF, or the greatest common factor, is 5. So we can factor out a 5 to come out in front. Okay, we still don't know what's left inside our parentheses, so now we are going to take that 5 that we factored out, and factoring really just means divisions. We're going to take this 5 and each of our coefficients, divide it by that 5. So the first one, 10 divided by 5 to get us our first coefficient, that is going to be 2. 10 divided by 5 is 2. Okay, our second one, 5 divided by 5 is going to be 1. Okay, we're going to have that plus in the middle of them. Okay, so we have a 2 plus 1 left over when we factor out that 5. Awesome. Now we need to look at the variables, the r's. Okay, so we have 4 r's in our first term and 1 r in our second term. Okay, if I were to draw this out, r to the fourth is just saying r times r 4 times, and then 1r. Okay, now we need to ask the question, how many r's do they have in common? The first term has 4, like I said, the second term has 1, so we know that they both at least have 1. One of them can come out next to that 5. We can factor out 1r because they have that in common. Okay, now we need to, again, divide each term by what we factored. So now we have r to the fourth divided by 1r. Okay, and I'll bring this over here so we can see division with exponent rules again. Again, r to the fourth, we can rewrite r times r times r. When we divide by 1r, those cancel out, we get r to the third. Or in other words, you could have thought r to the fourth minus 1 equals r to the third. Same thing. Okay, so we know that when we divided this r by fourth, we take away 1, we had 3 left over. Or 2r to the third. Sorry, that's really little. I'll rewrite it here in a second. Okay, now let's go to our second one. We have 1r, we take away, or we factor 1r. So we'll just do that really quick right here. Okay, r divided by r, that just leaves us with an invisible 1. 1 times 1 is just 1. So that 1 does not change. The r's got factored out. We had 1r, it was factored out, so we're not left with any over here. Okay, so I'll rewrite this as our answer so you guys can see it. So we had 5r. I was able to factor out. Inside left over was a 2r cubed plus 1. And that is our answer. It is all factored. 5r times 2r cubed plus 1. Perfect. Okay, let's move on. Again, you guys can pause, rewind, whatever you guys want. But let's go to number 2. Okay, number 2, it's asking us to factor completely. Okay, this is no longer a binomial, meaning we don't have just 2 terms anymore. We have 1, 2, 3 terms. Okay, this is called a quadratic expression. So when we are factoring a quadratic expression, we need to draw a little t-chart, our factor chart, under our last term. Usually it's a constant. There are no variables attached. Okay, so our last term is 40. What we need to do is we need to decide what two numbers multiply to give us 40, right, our little factor chart, but then add together to give us our middle term of 13. Okay, so I suggest just making a t-chart really quick. 40, we have 1 times 40, that would be 41, not quite. 2 times 20, that would be 22, not quite, so let's keep going. 3 is not a factor. 4 times 10, not quite. Okay, but let's keep going. 5 times 8, and hold on, 5 plus 8, right? We have 5 times 8 will give us 40, but then 5 plus 8 will give us 13. Okay, check. These are our two factors that add to 13. Again, add to 13. In fact, I'll write that down. 5 plus 8 equals 13. That is where I'm getting that number from, but they multiplied to give us our last number of 40. Okay, once we have our two factors that work, all we have to do is rewrite them as factors. Okay, so we always have our two parentheses. In front we have our x's because it was x squared, so x times x. Okay, and we add a positive 5 over here, multiplied by a positive 8 over here. And that is factored. That is it. Awesome. Okay, moving on. Last one that I will do as an example, and then you'll have problems just like these to do on your own for your assignment. Number 3, now we are solving the equation by factoring. Notice that the only thing that it's added on is this plus 0, or equals 0 at the end, excuse me, equals 0. That tells us we actually need to solve for a, find what a is. Okay, we're gonna start it the exact same way though. We are going to factor this side. So draw your little t-chart under 48, okay? That is the number that we are trying to multiply, get numbers to multiply to. Okay, so we can start writing our little t-chart. 1 times 48, that's going to give me 49, not quite. 2 times 24, still not quite. If you need a calculator, you're more than welcome to. Find these factors. Okay, we have 3 times 16, not quite. That's going to give us 19 right there, so we'll keep moving on. 48 divided by 4, or in other words, 4 times 12. Okay, that's again going to give us 16. We're almost there. 5 is not a factor. 48 divided by 6. Let's try 6. 6 times 8. And we know that these two, when added together, 6 plus 8, will give me that 14 that we were looking for in the middle. Okay? So we know that 6 and 8 were the factors that we were looking for. So we can rewrite them over here. Just like we did last time, we have a this time. So in the front of my parentheses is going to be an A and an A. I had a positive 6 right here, so plus 6, and then a positive 8 right here, so plus 8. The only thing I need to add on is that equals 0. Okay, it is all factored, but it is not solved. The only thing we need to do now is take each one of these little pieces, okay, a plus 6, and set it equal to 0, and then the other one, a plus 8 equals 0. Now we are actually going to solve it. Okay, these are both one-step equations. To get a by itself, all you need to do is subtract that 6. The opposite of plus 6 is minus 6. Subtract 6 from both sides. Our first answer is a equals negative 6. Okay, let's do it over here. Opposite of plus 8, subtract 8. Do it from both sides to get a by itself. So our other answer is negative 8. Okay, you will get two answers. You'll always get two answers when it is a quadratic equation, meaning that there is an a squared with a single a in the middle right there. Awesome. Okay, those are our examples for today. You will have 3 to do on your own. You should have these notes in front of you if you either printed them off from Canvas or if you came into the school and got them. Okay. Okay, they are available to you. Again, either print it off, submit it through Canvas by scanning it or sending a picture, or go straight to wootmath.com and this same assignment is there. You can do it virtually that way. Okay, awesome. Thanks, guys.